right, well, thank you very much to the organizers for inviting me. This is my first GopherCon, and I'm having a great time. What about you guys? Yeah? All right. I'm super excited to talk to you guys about Go for data science. Today, I'm going to give you a little bit of a story about how I came to talk about using Go for data science. And along with that, I'm going to share a little bit about what data science is and some struggles that data scientists are feeling. Then we're actually going to do some data science with Go. And finally, I'll give you a few resources that you can look to get your feet wet and start contributing. All right, so let's talk a little bit about how I came to this place of doing data science with Go. And I started out in computational physics. I got my PhD at Purdue, and during that time, I developed a theoretical framework for electrons impacting atoms and molecules. And I actually developed some algorithms that made this type of calculation computationally feasible, and implemented those in an open source code in Fortran. And that code's actually still being used today. Well, I eventually found my way out of academia and started working as a consultant with an IP firm. And then I found out about this really interesting field called data science, which wasn't too far away from the traditional research that I had done previously, and where people were using some of the skills that I had to solve some interesting problems in industry. So I got a gig with a VoIP startup called Telnix as a data scientist, and started to figure out that I could apply some of the probability distributions that I had used to describe electrons, and I could apply those to, say, predicting the costs of Telnix services, and was able to reduce error in their predictions from like 45% to around 7 to 10%. And then I could use things like time series analysis that I had used to describe electrons scattering off of molecules, and apply that to develop a service that would detect fraud in our network traffic. And eventually was able to build up a team of data scientists and engineers there that are still doing some really great work developing data-driven services and dashboards and reporting tools and that sort of stuff. But when I came into Telnix, I was primarily working with Python, both because it seemed like a lot of data scientists were working in Python, and a lot of the software engineers at Telnix were working in Python. But by the time I left Telnix, I was actually primarily writing Go to do data science. So what happened? How did this occur? It really comes down to the fact that Go was able to alleviate the main struggles that I was feeling as a data scientist working in Python. And that's what I'm going to share with you today. But before we do that, let's kind of come to a common understanding about what data science is. Even if you're not a data scientist in the audience, you might have heard about certain things going on in data science that I like to call hashtag data science. So you might have heard about some cool team of data scientists who wrote this amazing algorithm to do some extraordinary predictions. So for example, a team of data scientists and engineers at Google recently trained an algorithm based on the neurons in our brain, so called a neural network, to make predictions that allowed it to beat the Go grandmaster at the board game of Go, which is a board game that's much more complicated than chess. And this is just amazing and extraordinary. But I found that most data scientists in industry don't spend a lot of time training algorithms to play board games. They're mostly interested in transforming data that a company is generating, or data that they can gather from wherever, and transforming that into insights that a company can use to make decisions. And primarily that involves a few different tasks, okay? So as a data scientist, we have to move data from one place to another. We might have to clean it up a little bit, organize it. We also might want to parse some values out. We might want to extract some patterns For example, we might want to extract like a time series of metrics from server logs or something like that. And then finally, we'll want to probably do some type of arithmetic. So this arithmetic, it may be as complicated as training a neural network, but a lot of times maybe it's just calculating a maximum value or mean value, or aggregating a bunch of values and displaying like gross profit and cost on a dashboard or something like that. But generally, these three activities are needed to make that transformation of data to insights. So I mentioned, as a data scientist working in Python, I began to feel some struggles in performing these three activities in Python. And these struggles really center around integrity. So as a data scientist, I was writing Python code. I felt like I was doing something really cool, and then I would deploy my application, and I felt like it didn't really have a lot of integrity because it would run good for a while, and then it would start to behave strangely. And so I would look at the logs coming out of Python, and it looked like everything was going as planned. So I couldn't really figure out what was going on. And as a result of this, my application behaving strangely, people began to lose faith in that application, right? So this is a big problem. And where I felt like my integrity was kind of failing was in a couple of areas. So the first had to do with reproducibility. Like I said, I was developing some really cool code and what I thought was a cool model, and then deploying it, and then my head would be left spinning because I couldn't figure out why it was behaving the way it was. It seemed like it should be doing what I expected, but it wasn't. And let me give a very simple example to illustrate this. So because I'm only interested in big data, let's look at this data set here. It has 3 rows in it. And it seems that we have an integer column and we have a string column, right? And without too much more trouble, we can write a Python script that will read in this program and print out the maximum integer value. And we can also write some Go code that will read in our CSV. It'll parse the records, and then we can loop over the records and print out the maximum integer value, handling any error as we parse them. OK, and if we run both of those, we get we get what we want. We get what we expect. They both print out the value of, which is the maximum value in that integer column. But what happens if something went wrong with the way that we generated our data, something went wrong in our data pipeline, and we get some missing values? So let's take out that value of 3. Now, being a room full of Go programmers, you would probably expect the Go program to throw an error, which you hope it will. But it's maybe not so clear what's going to happen in the Python case. Maybe you guys have some guesses. But this is actually what happens. Python code still runs and returns a value. It returns 2 in this case. And apparently, our integer is now a float. I'm not sure entirely why that is. But in any case, if we were looking at this, it would look like this program just ran as we expected and printed out a value. And so I really had no transparency into the fact that something different happened under the hood, but I had no idea about it. Whereas with Go, I'm able to handle these cases, and I'm able to maintain the integrity of my code and the reproducibility of my code, and actually have some confidence in the results that I'm generating. All right. So the next place I think I was failing with respect to integrity was in terms of deployment. And I always felt like, again, I would be writing these cool Python data science-y applications, and I felt like when I went to deploy them, I had to sit around the war table with my DevOps friends and figure out where we were going to put all the pieces of the Python data science ecosystem and what version and what cloud, and such that I could deploy my application on the X and have it behave as expected, which eventually became really annoying and hard. And as a result, the DevOps people generally didn't like my data science applications. And maybe that's where some of you DevOps people are. But let's see how Go can help us maintain integrity here with another example. So even if I was nice and I wrote myself a Docker file for my data science application in Python, it generally would look something like this. Hopefully you guys can read all that. It was still a nightmare. And with a build like this, it was impossible for me to maintain the integrity of my application. But as I transitioned to doing things in Go, I felt a little bit more like this. I felt like I could write my application, and then I could compile it to a binary, and I could just drop that thing right on the X, and it would behave as I expected. So it both eased the burden of deployment, but also gave me, again, more confidence that what I was deploying was going to behave the way that I expected. And then my Docker files eventually started looking like this. So really, by taking a Go-based approach to data science, I've, again, eased my struggles, come up with a way to maintain integrity of the code that I was generating. And as an added bonus, I, of course, get the scaling and efficiency benefits that are well known in Go. So at this point, I mean, there's no reason to not use Go for data science, in my mind. So with that in mind, let's actually try to do some data science with Go. Let's put these guys to work on an example project. And again, being a room full of Go devs at GopherCon, let's try to actually generate some insights about the Go community using Go and data about Go, if you follow that. Specifically, in a data gathering and organizing phase, let's try to gather some data about Go repositories on GitHub, extract some values, and then see what we can learn from those values, and eventually make a prediction about something hopefully of interest to you guys. To do this, we're going to, this part of the project, we're going to use Google's Go GitHub package, which will allow us to do these queries. Let's look at some example code. You can see here on line 14, I'm importing that Go GitHub package, and then I'm going to handle my errors with Dave Cheney's errors package here. And in my function main, what I'm going to do is I'm going to define a start date, and then I'm going to query GitHub for all Go repositories created after that start date. And in that query from start time function, this is where the meat of things happen. At line 34, I'm going to define my new GitHub client, and then I'm going to loop over 2-day periods from my start date till now, because by default, GitHub will only respond with a certain number of results, so I need to split this up. And then finally, in this client query, I'm going to supply some GitHub options at line 72, and then I'm going to loop over pages in my results, gathering for each repo certain things that I'm interested in: forks, issues, stars, size, updated at timestamp, and other good things. So eventually, I'm going to print those out to standard out, and then I'm going to sleep for 10 seconds to stay within GitHub's rate limiting constraints. And because of those constraints, this takes a little bit to run, so I ran it prior to this demo and redirected the output to a CSV. And that CSV looks like this. So you can see that here I have a bunch of Go repositories and created at, updated at timestamps, and counts of forks, issues, stars, and then finally a size and bytes of those Go repositories. Great. So I've gathered my data, and I've organized it in a nice way. But as a room full of smart gophers, you're probably thinking, can't we do better than outputting to a local CSV? In some cases, you probably don't want to output to a local CSV. And the answer is yes, we can do something a little bit interesting here. And we can do something that will, again, help us maintain the integrity of our data and help us with reproducibility. So we're going to use a tool called pachyderm, which is also written in Go. And pachyderm gives us two things. So it gives us a containerized data pipelining system built on top of Kubernetes, which is an amazing system, which you should try out. But it also gives us a file system called PFS. And that file system will let us actually commit data into PFS, similar to how we would commit code into GitHub. So now we're actually versioning our data. And at any point, we can go back in history and pull out any commit we want from the data that we've committed into pachyderm, which is great for reproducibility, and it really alleviates a lot of struggles in data science. So let's see how that might work. Here, here's another example program to push that file we created into pachyderm. As you can see, I'm importing the pachyderm client, and I'm just going to do one thing. I'm going to push that CSV file I generated into a data set called repo data in pachyderm in a repository called Go data. And in pushing, I'll read in that file. I'll create a new connection to pachyderm, create that repository, and then at lines 49 through 63, I'm basically doing this git-like commit of data into PFS. So here, first let's use pachyderm's command line tool called packcontrol to see what repositories I currently have in pachyderm. I have a backup one here that I created before, but that's the only one in there right now. And here's my program. So let's go ahead and build that. Now I have my binary, so let's execute that. Then if I look again at what's in my repository, now I have this new repository called Go data, which I'm going to be able to commit data into in version. And that was created 3 seconds ago. It has 10 megabytes of data in it. And I can even look at the commit history of that repository and see I've made one commit 20 seconds ago with 10 megabytes of data. And of course, as you rerun your programs, as you rerun your data pipelines, you can commit at all stages of input and output data and basically give you complete reproducibility of any experiment that you make, which is just awesome. OK, so we've gathered our data. We've stored it in a responsible way that's going to help us maintain our integrity. Now let's get to some arithmetic and maybe some visualization. So at this point, some of my Python colleagues might offer to help because they're not sure Go is very suited for this. But as a gopher at GopherCon, I'm proud to say, nah, we got this. So actually, what we're going to do is utilize some packages from this GoNum project, which is a really great series of packages, data science-y related packages that will let you do a whole bunch of things. So they'll let you do numerical integration, matrix manipulation, plotting, graph-based algorithms, and more. But to start out here, let's just start doing some visualization. So as a data scientist, a lot of times what we want to do after we've gathered our data is we want to get some intuition about what our data looks like. And to do that, we oftentimes like to use plotting, make some pretty pictures. Particularly, a lot of times we're interested in how a certain variable is distributed. And to learn a little bit about that visually, we usually use histograms. So let's try to use GoNum's plotting package to generate some histograms. Specifically, let's try to use GoNum's plotting package to generate some histograms of star values, star counts of our Go repositories. So here in this example, again, I'm importing my plotting package here. I'm importing the pachyderm client so I can pull my data out of pachyderm. And I'm going to do two things. I'm going to prepare my data for plotting, and then I'm going to make and save those plots. So to prepare my data, I pull it out of pachyderm where I put it before, and I create two plotter.values variables. And as I loop over records in my data set, I'm going to put in the count of stars, which is the 5th value, into one of those variables. And because I have a certain suspicion as a data scientist that this is going to be a very skewed distribution, which might not be very interesting to look at, I'm also going to put the log of that value in there. So let's see how this would go. Here's that example. Let's go ahead and build it. All right, so there's my executable. Let's see what we got. All right, so now we have these two histograms. Okay, and if we look at what those look like here, you can see this is the raw star values. It doesn't end up looking super interesting because actually a lot of repos have 0 stars, right? But then if we look at the second one, which was the log of our star values, we can see that's a little bit more interesting. And again, at this stage, we're trying to learn how the variable is distributed, and GoNumPlot allows us to do that very easily without too much trouble. OK, so we've done our data gathering, we've done our organizing, we've maintained integrity of our data in pachyderm, we've made some plots. Now let's actually try to do some prediction. And the prediction that we're going to try to make is how many Go repositories are going to be created at some future date of interest. Okay? To do that, we're going to use this Sajari regression package. But before we do that, let's just try to get a sense of how the number of Go repositories created daily has increased over time. So let's create a plot that will show us that. All right. So here, let's see. Here, I'm going to import my plotting functionality again. And in this case, in my function main, I'm going to prepare some count data. And then I'm going to plot that count data. In preparing the count data, what I'm basically going to do is create a map that will store the daily counts of Go repositories created historically. As I loop over my records, I'm just going to see what the interval is between my start date and the date that Go repository was created, and I'm going to increment that value. Finally, I'm going to sort those values to make my plotting look a little bit nicer. So let's go ahead and see what that looks like. All right, build this. And run it. And now you can see that we've created this plot of these counts that we counted for all the Go repositories. Let's look at that. All right, that looks something like this. So you guys are doing good. You're increasing over time. And actually, if we take a little bit closer look at this plot, just to give you some reference, those are over the years and how we've been creating more and more Go repositories. So great job. Now you can notice that we've kind of got almost a linear trend here, right? So let's try to fit a line to this historical data and see if we can make a prediction about how many Go repositories will be created on some future date. All right. So here in this example, again, going to be importing some plotting stuff, but also this regression package at line 24. I'm again going to prepare the counts of my data, prepare some things for plotting, but then I'm going to perform a regression on this historical data. Okay, after performing that regression, I'm going to prepare some other values for plotting, except in this case, I'm going to use my regression to make some predicted values. So I can see what my predicted values look like against my observed values. And finally, I'm going to make 2 predictions. I'm going to make a prediction about how many Go repositories will be created today, and how many Go repositories will be created a year from now. So GopherCon 2017. All right. So here's that. Let's go ahead and build it. And when I run this, it's going to output those predictions. And then it's also going to create a plot of the observed and predicted values. So let's do that. OK, great. It went pretty fast. So here's our predictions, which I'll show in a graph in a moment. But also, we've outputted this regression plot. Let's take a look at that, because it might be easier to look at this visually for a second. All right, and here's our actual and predicted values. You can see our line tracks pretty well with the historical values, and will allow us to make some future predictions. So coming back over here, that's what we just saw. All right, so today, according to my model, we're going to create 195 Go repositories on GitHub. It might be slightly weird, since most of the Go programmers are in this room not making Go repositories. But anyway, around this time, assuming GopherCon didn't happen, it would probably be around 195. But next year, when we get to GopherCon 2017, you guys have to follow up on this. You should be creating about 250 Go repositories every day. So don't disappoint me, and try to beat that number. OK, so we've shown that we can apply an entirely Go-based approach to a data science project from start to end. We've showed that not only can we do that, but we can do it in a way that alleviates the struggles that a lot of data scientists are feeling in industry. So my challenge to you now is to go forth and start doing some data science with Go. I've provided, these slides will be up on my GitHub. But again, these were the packages I used for my little demo here. So make sure to check those out. But there's a lot of other great data science-related packages in the Go community. And I don't think this gets out as much as it could. So please take a look at these links. There's some really great stuff happening. The GoBot people who are doing IoT stuff, they're here at GopherCon, and I think that they're going to be doing some stuff on the Hack Day. There's another personal project of mine, Gopher Notes, which will allow you to do some interactive Go programming in the browser. And I would love some help with that if you're so inclined. But anyway, just try it out. There's general purpose machine learning. There's MapReduce. There's really a whole lot going on in the Go community. So play around with these things and contribute to them because they're awesome. There's also other things on the roadmap in general. There's a proposal for multi-dimensional slices or tables in the Go language. And it seems like there was some activity on that recently. And I'm happy to see that. And maybe if you guys have opinions about that, I think this is a great place to discuss that sort of thing. So let's follow up. There's also now a Go API for TensorFlow that's being worked on, which is a framework that will, remember how I talked about teaching an algorithm to play a board game. You could do that with TensorFlow, and now you could do that right from Go. Also, there's stuff happening with Apache Beam and other projects from the Go perspective. So this is really a great time to jump in, get started, try out some things in the Go community related to data science. Also, get on Gopher's Slack, respond with questions later. There is a data science channel in Gopher's Slack, so find that and let's discuss things. And thank you guys very much. It's great to be here.